Hi everyone, welcome back. In this example, we're going to get a little bit of practice with the scale command. And we're going to also use scale to talk about how to achieve a mirror effect. Because if we scale using negative values, essentially we can reverse things around the origin. So that's something we can take advantage of to treat the origin as a line. We can sort of create a mirror effect around. So before we can demonstrate scale, we need something to work with. So for this example, we're just going to create a simple kind of drawing tool, very basic. So let's use the mouse drag function in order to do this. I'm going to use mouse drag here. And in the past, we've kind of demonstrated mouse drag. We could do something like set a white fill and then maybe draw a white stroke and draw a circle, using mouse X, mouse Y, small circle. And we could kind of use this to create a simple drawing tool. And let's move background to setup as well. So take that out of setup. Okay. Right, so we've done things like this in the past. Now, just to make things a little different in this example, we're going to draw a little bit of code that's going to allow us to connect the dots. So here, if I move quickly my cursor, right, the size of the circle, right, doesn't really quite cover the gap between the space between two frames. So where the mouse currently is and where the mouse used to be in the previous frame. So instead of drawing like this, we are going to literally connect the dots by drawing a line between the mouse cursor and the mouse cursor's position in the previous frame. Now, thankfully, we have access to this in the way of two global variables called pmousex and pmousey. So if mouse x and mouse y are where the current mouse cursor is, pmousex and pmousey point us to the previous position of the cursor. So just to make things extra clear here, we're going to create four variables. Let's call them x1 and y1. So that's going to be mouse x. And then x2, that's going to be pmousex. And y2, it's going to be pmousey. Okay? So that gives us 2 points, right? So this is where the mouse is. This is where the mouse used to be, because there's a p in front of it. This is another global variable. We just haven't used it before. And we're going to connect these 2 points with a line. So line between y1, x1, y1, and x2, y2. Let's run the code. And now we can draw continuous lines whenever we do mouse drag. Okay. If we jump really, really fast, it's going to become apparent that these are just connected with straight lines. Okay. But this is kind of a way we can start to approximate, a bit of a basic drawing tool. We can also, make things a little bit more interesting if, let's say, we varied the thickness of the stroke based on like how far the mouse has come between this frame and the previous frame, right? So we know that we can measure that distance between the endpoints of the line. We can do that using the dist function. We've used that one before. So I'm going to measure the distance between the two endpoints of that line. Okay? And we're going to just use that distance as the stroke weight. So stroke weight sets the line thickness. So let's see what happens if we do that. So now if I move slowly, I have a small stroke weight. And if I move quite fast, I get a much bigger stroke weight. Okay, so that allows me to create these lines here. Obviously, when I change the stroke weight, it creates kind of these oval shapes for the line. That's just what P5 does. So it's kind of interesting. It looks like these sausage links, I guess. If we wanted to make like a smooth, brush stroke, for example, we could do that, but it would turn this example into a 2-hour example. We're not gonna, this is not the scope or the point here. We would have to calculate smoother geometry along this line instead of relying on stroke weight. So we'll just use stroke weight as a way to add interest to these lines based on my speed of movement. So just to make it more interesting. All right, so let's talk about scale, because that's the whole point of this example. What I would like to do with scale is take advantage of the fact that if we put in negative numbers inside scale, everything we draw is going to be mirrored along whichever axis we specify. So if my origin is over here and I put a scale of -1 before I draw a line, okay, and actually let's set the stroke weight before we draw the line, that would make sense. If I, let's say, do a scale of -1 here, and 1 on the y-axis, I'm not going to see anything, right, unless I guess go really close here to the edge. So this basically means everything I'm drawing is appearing over here. Okay. So if we wanted to say mirror along the middle point of the screen, so that if I draw something over there and it appears over here instead, I would have to first move the origin so that the x-axis is no longer, sorry, the y-axis, right, is no longer over here, but over there. In fact, here I'm mirroring along x, which is not necessarily what I intend to do. Okay. But let's fix that in a second. So first, let's move the origin, right? We're going to translate and move the origin up here so that it is now in the middle of our window. Okay, so we're going to say translate width divided by 2, and we'll leave the origin at 0 on the y-axis for now. Okay. All right, so this is what we get now. Okay. Now, this is not really the mirror behavior I was expecting, and the reason for that is because, don't forget, once we've moved the origin, right, the mouse cursor doesn't know about these transformations. So if we made it so that our 0, 0 point is now over here, we have to take that into account when we draw and when we use these coordinates over there. Okay, so in other words, the origin is now here. We need to subtract, right, half of the width from the mouse coordinate so that it becomes negative when it passes the middle point. So we're going to say minus width over 2 and minus width over 2, both for x1 and x2. All right. So now when I draw over here, because I applied a negative scale on the x-axis, right, the x-axis over here, everything appears on the other side of that imaginary middle line I have down here from having translated the origin, and then vice versa over here. Okay? If I draw over there, and of course if I cross the middle point, things happen. Things are being mirrored along whatever the origin line is located. So if my x value is over here, the mirroring effect happens over there. Now, one interesting thing we could do here is, like, if we wanted to see both lines, like both what I'm drawing but the mirrored line as well, we could use push and pop to do that and then draw a couple of lines, right? So if this is my original line, we could say draw the line, right? And then draw this line, but then scale it along the x-axis. I'm going to use push and pop to make sure that anything I draw afterwards is not going to get affected by this. So now we're going to draw two lines. Okay? So we have the line that's under my cursor, but then we also at the same time get the mirrored line, right, along the x-axis, right? So wherever the x value is located, when I mirror along that, I get my values basically reversed. Okay? So that allows us to create very simply these sort of like mirror effects using scale. Okay, so scale is, I'm using 1 here because I don't necessarily want to make one side bigger. If I said -2, right, the other side would be twice as big, so that kind of breaks the symmetry. But if I just do -1 here, it means that there's no change on the y-axis, but the x-axis is flipped. So that's a useful tool. We could also do the same thing along the y, right? We could do something where if we draw in a quadrant up here, it would replicate the same thing on the bottom and then on the bottom right. So let's move our origin to the center in translate here. I'm going to move the origin to the center. So now 0, 0 is over here. So we're going to be mindful to change our coordinates here so that when the mouse is up here, I want to get negative y values, right? And negative values on the x, but positive down here, okay? And positive down here. So we're going to offset this by half the height as well, just like we did with the x values. And that's because mouse x, mouse y right? P mouse X mouse Y, they don't know about these translates. They assume 0, 0 is up here, but we've just moved it to the middle. So we gotta tell it to offset itself. Very good. And now that the origin is in the center here, we can also flip things along, let's say the y-axis, right? We could say this other line here, we're going to flip it along the y-axis instead. So now I'm going to have 3 lines that appear, one mirrored along the x, one mirrored along the y down there. Okay? And of course, they all connect back to the middle. And then we could draw the 4th one, doing the same thing. I'm going to copy and paste this section again. The 4th one, right, I would want to mirror, oops, didn't mean to delete that. For the 4th one, I would want to mirror along both x and y together, right? So flip around the x, flip around the y. So that will give me this bottom area over here. So now if I draw up here, -1, -1. Interesting, I should see 4. Oh, I don't know why I accidentally messed up my copy and paste, I guess. Yeah, this one, I don't know how it flipped. So this is mirror along x-axis, mirror along y-axis, mirror along both x and y axis, right? My bad. So now I should see 4 shapes being drawn when in fact, you know, my mouse cursor is in one place, right? And I'm drawing the same line 4 times. The only difference is what scale I'm setting each time. Okay? Now we've created kind of a really basic mirrored drawing tool. So really simple framework, but you know, something if you want to challenge yourself, you could definitely play with and expand on. The idea here was to demonstrate the scale function and how we can use it to create mirror effects. All right, so we're going to leave it at that for this example, and we're going to do one more. The next one we're going to talk about when we do want to stack transformations to create an effect, and I will see you in the next video.